The industrial, scientific and medical radio bands are radio bands reserved internationally for the use of radio frequency energy for industrial, scientific and medical purposes other than telecommunications. Examples of applications in these bands include radio frequency process heating, microwave ovens, and medical diathermy machines. The powerful emissions of these devices can create electromagnetic interference and disrupt radio communication using the same frequency, so these devices were limited to certain bands of frequencies. In general, communications equipment operating in these bands must tolerate any interference generated by ISM equipment, and users have no regulatory protection from ISM device operation. Despite the intent of the original allocations, and because there are multiple allocations, in recent years the fastest growing uses of these bands have been for short-range, low-power communication systems. Cordless phones, Bluetooth devices, near-field communication devices, and wireless computer networks all use frequencies allocated to low-power communications as well as ISM. ISM bands. The ISM bands are defined by the ITU in 5.138, 5.150, and 5.280 of the radio regulations. Individual countries' use of the bands designated in these sections may differ due to variations in national radio regulations. Because communication devices using the ISM bands must tolerate any interference from ISM equipment, unlicensed operations are typically permitted to use these bands, since unlicensed operation typically needs to be tolerant of interference from other devices anyway. The ISM bands share allocations with unlicensed and licensed operations. However, due to the high likelihood of harmful interference, licensed use of the bands is typically low. In the United States of America, uses of the ISM bands are governed by Part 18 of the FCC rules, while Part 15 contains the rules for unlicensed communication devices, even those that share ISM frequencies. In Europe, the ETSI is responsible for governing ISM bands. The ISM bands defined by the ITU are, regulatory authorities may allocate parts of the radio spectrum for unlicensed communications that may or may not also be allocated as ISM bands. History. The ISM bands were first established at the International Telecommunications Conference of the ITU in Atlantic City, 1947. The American delegation specifically proposed several bands, including the now commonplace 2.4 GHz band, to accommodate the then nascent process of microwave heating. However, FCC annual reports of that time suggest that much preparation was done ahead of these presentations. From the proceedings, the delegate of the United States, referring to his request that the frequency 2450 MCS be allocated for ISM, indicated that there was in existence in the United States, and working on this frequency a diathermy machine and an electronic cooker, and that the latter might eventually be installed in transatlantic ships and airplanes. There was therefore some point in attempting to reach world agreement on this subject. Radio frequencies in the ISM bands have been used for communication purposes, although such devices may experience interference from non-communication sources. In the United States, as early as 1958 Class D Citizens Band, a Part 95 service, was allocated to frequencies that are also allocated to ISM. 1. In the U.S., the FCC first made unlicensed spread spectrum available in the ISM bands and rules adopted on May 9, 1985. Many other countries later developed similar regulations, enabling use of this technology. The FCC action was proposed by Michael Marcus of the FCC staff in 1980 and the subsequent regulatory action took 5 more years. It was part of a broader proposal to allow civil use of spread spectrum technology and was opposed at the time by mainstream equipment manufacturers and many radio system operators. ISM uses. For many people, the most commonly encountered ISM device is the home microwave oven operating at 2.45 GHz. However, many different kinds of ISM devices exist, which are predominantly found outside dwellings. Many industrial settings may use ISM devices in plastic welding processes. In medical settings, Shortwave and microwave diathermy machines are ISM devices mostly commonly used for muscle relaxation. Microwave ablation, a type of interventional radiology, is an ISM application which treats solid tumors through the use of RF heating. Some electrodeless lamp designs are ISM devices, which use RF emissions to excite fluorescent tubes. Sulfur lamps are commercially available plasma lamps, which use a 2.45 GHz magnetron to heat sulfur into a brightly glowing plasma. Long-distance wireless power systems have been proposed and experimented with which would use high-power transmitters and rectennas, in lieu of overhead transmission lines and underground cables, to send power to remote locations. NASA has studied using microwave power transmission on 2.45 GHz to send energy collected by solar power satellites back to the ground. Also in space applications, a He-like double-layer ion thruster is a prototype spacecraft propulsion engine which uses a 13.56 MHz transmission to break down and heat gas into plasma. Non-ISM uses. In recent years ISM bands have also been shared with license-free error-tolerant communications applications such as wireless sensor networks in the 915 MHz and 2.450 GHz bands, as well as wireless LANs and cordless phones in the 915 MHz, 2.450 GHz, and 5.800 GHz bands. Because unlicensed devices are required to be tolerant of ISM emissions in these bands, unlicensed low-power users are generally able to operate in these bands without causing problems for ISM users. ISM equipment does not necessarily include a radio receiver in the ISM band. In the United States, according to 47 CFR Part 15.5, low-power communication devices must accept interference from licensed users of that frequency band, and the Part 15 device must not cause interference to licensed users. Note that the 915 MHz band should not be used in countries outside Region 2, except those that specifically allow it, such as Australia and Israel, especially those that use the GSM 900 band for cell phones. The ISM bands are also widely used for radio frequency identification applications, with the most commonly used band being the 13.56 MHz band used by systems compliant with ISO IEC 14443, including those used by biometric passports and contactless smart cards. In Europe, the use of the ISM band is covered by short-range device regulations issued by European Commission, based on technical recommendations by CEPT and standards by ETSI. In most of Europe, LPD 433 band is allowed for license-free voice communication in addition to PMR 446. Wireless LAN devices use wave bands as follows: Bluetooth 2450 MHz band falls under WPAN, HIPLAN 5800 MHz band, IEEE 802.11/Wi-Fi 2450 MHz and 5800 MHz bands, IEEE 802.15.4, Zigbee and other personal area networks may use the 915 MHz and 2450 MHz ISM bands because of frequency sharing between different allocations. Wireless LANs and cordless phones can also use bands other than those shared with ISM, but such uses require approval on a country-by-country basis. DECT phones use allocated spectrum outside the ISM bands that differs in Europe and North America. Ultra-wideband LANs require more spectrum than the ISM bands can provide, so the relevant standards such as IEEE 802.15.4a are designed to make use of spectrum outside the ISM bands. Despite the fact that these additional bands are outside the official ITUR-ISM bands, because they are used for the same types of low-power personal communications, they are sometimes incorrectly referred to as ISM bands as well. Also note that several brands of radio control equipment use the 2.4 GHz band range for low-power remote control of toys, from gas-powered cars to miniature aircraft. Worldwide Digital Cordless Telecommunications or WDCT is a technology that uses the 2.4 GHz radio spectrum. Google's Project Loon uses ISM bands for balloon-to-balloon and balloon-to-ground communications. Pursuant to 47 CFR Part 97, some ISM bands are used by licensed amateur radio operators for communication, including amateur television. See also, frequency allocation, fixed wireless, electromagnetic interference at 2.4 GHz, references, Article 1, Terms and Definitions Life ch. International Telecommunication Union. October 19, 2009 1.15. Industrial, scientific and medical applications, operation of equipment or appliances designed to generate and use locally radio frequency energy for industrial, scientific, medical, domestic or similar purposes, excluding applications in the field of telecommunications. Documents of the International Radio Conference, Doc. Number 1 to 100 PA 464A, I 13th Annual Report of the FCC, June 30, 1947 I pages 8, 50 to 51 http, Transition FCC Gov Mass Media Documents Collection 1947 PDF. Authorization of spread spectrum systems under Parts 15 and 90 of the FCC Rules and Regulations. Federal Communications Commission. June 18, 1985. Retrieved August 31, 2007. The Genesis of Unlicensed Wireless Policy. George Mason University. April 4, 2008. Retrieved April 20, 2008. External links, Cordless phone frequencies, ITU page on definitions of ISM bands, ITU page on radio regulations, European Radio Communications Office Frequency Information System, in the U.S., CFR Title 47 Part 18 describes the regulation of the ISM bands. 1. Contains some of the regulations for wireless LAN devices operating in 3 of the low-power communication, Part 15, bands.